In this video, we're going to talk about finding trig functions for any angle and something called the unit circle. So first of all, let's suppose we have a point xy here. So our point is there, and it is a distance of r units away from the origin. And this angle, theta, is made with the positive x-axis here. So we can define the trig functions using the coordinates x, y, and that distance r. Now it follows from the definitions we had earlier. Previously we said that sine theta is equal to the opposite side over the hypotenuse. Well, what we can see is that the opposite side in this imaginary triangle would be y, and the hypotenuse would be r. So we would say y over r here. Similarly, for cosine, well, cosine was adjacent over the hypotenuse. So in this triangle, the adjacent side is x, the hypotenuse is r here. So we can proceed in this fashion for the remaining trig functions. So tangent is opposite over adjacent, so this is going to be y over x. Cosecant is just the reciprocal of sine, so sine was y over r, so cosecant is r over y. Secant is the reciprocal of cosine, so that's going to be r over x. And then cotangent is the reciprocal of tangent, which is x over y. So let's use these coordinates to answer this question. Suppose theta is an angle whose terminal side contains the point 2, -5. Find the value of the 6 trig functions for theta. So to answer this, we want to plot the point 2, -5, and then we want to draw a triangle, a right triangle with the x-axis. So what we have here is this angle in here, let's call that theta. And then 2 is along the x-axis, -5 is along the y-axis. So what we need to do is we need to solve for this r value. And we just use the Pythagorean theorem. So r squared equals 2 squared plus -5 squared. We get r squared equals 4 plus 25. R squared equals 29. So r is equal to square root of 29. So this value in here is square root 29. Now once we have all three sides of this triangle, or in other words, once we have x, y, and r, we can go ahead and find the trig function values for this angle. So sine theta is going to be y over r, so that's going to be -5 over square root 29, and again we need to rationalize root 29, we get -5 square root 29 over 29. For cosine we have x over r, so this is going to be 2 over square root 29, and then rationalizing we get 2 square root 29 over 29. Tangent is y over x, so this will just be -5 over 2. And then for the reciprocal functions, we can just use what we originally found. So cosecant is the reciprocal of sine, so we're going to say square root 29 over -5. Secant is the reciprocal of cosine, so this is square root 29 over 2, and cotangent will be -2 over 5. One valuable concept in trig is the idea of the coterminal angle. So a coterminal angle is, or angles are coterminal if they're the same, if the two angles have the same initial side and terminal side. So what this means is if we have one angle that is positioned here, and then we have a second angle. Now, before I draw the second angle, this first angle, let's say, is right here, theta. It starts along the positive x-axis and it rotates to right here. So we get some angle theta. Now a coterminal angle to this first angle theta, well suppose the initial side again is along the x-axis, but this angle rotates all the way around and stops in the same position again. So this distance right here is still equal to theta, even though this angle went around, all the way around the coordinate plane one whole time, and then we went a little bit further, and that's that red angle theta. Now, what we would say is that these two angles are coterminal because they have the same initial side, so they both start, they both start along the positive x-axis, and they both end in the same position in the coordinate plane, even though this second angle rotated a further distance. And I'm just going to clarify and call this theta 1, theta 2. Now let's suppose theta 1 is equal to, how about 50 degrees? Now to figure out what theta 2 is equal to, what we do is, we take that 50 degrees, what we're going to do is we're going to add 360 degrees. So theta 2 we would say is equal to 410 degrees. So what we'd say is 50 degrees and 410 degrees are coterminal. Okay, so all coterminal angles are separated by 360 degrees. If we know one angle, to find a coterminal angle, all we need to do is add 360 to it. Now the last two things we want to say about coterminal angles is, first, the coterminal angles can be in degrees or radians. So to find, like what we did in this last example, to find a coterminal angle, what we did was we added 360 degrees. So to find a coterminal angle, we take our initial angle and we're going to add 360 degrees times some value k, where k is an integer. Okay, so that's if our angle is in degrees. Now if our angle is in radians, what we would want to do is we would want to add 2 pi times k, and again where k is an integer. Now this will make more sense when we do a couple examples here. So an a is an integer. And then secondly, it says coterminal angles can be positive or negative. Now let's look at an example here. Now this first angle, we're moving in a counterclockwise direction, and let's just give this some value. Let's call it, it's more than 90, let's call it 120 degrees. Now this second angle, if these angles are coterminal, and they are because they have the same ending position, they're both pointing in the same direction. However, in this one, I'm going, the angle is traveling clockwise, one whole rotation and then a little bit further. So because we're going in the opposite direction, we're going in a clockwise direction, we're going to minus or subtract 360. So we're going to say theta here, let's call this theta 2. So we're going to say 120 degrees minus 360 degrees. That'll give us negative 240 degrees. So the moral of the story is, to find a coterminal angle, we're either going to add or subtract copies of 360, or we're going to add or subtract copies of 2 pi. So let's look at a couple examples here. Given that theta is equal to 40 degrees, find 2 positive and 2 negative coterminal angles. Give the angles in both degrees and radians. So since theta is equal to 40 degrees, to find the positive coterminal angles, we're just going to add 360 degrees. To find the negative coterminal angles, we're going to subtract 360 degrees. So we would say 40 plus 360 times 1, so the k value here is equal to 1. So 360 times 1 is 360 plus 40, so 400 degrees would be one positive coterminal angle. Then what we're going to do is we're going to say 40 degrees plus 360 times a k value of 2. So 2 times 360 is 720 plus 40, that's going to be 760 degrees. Now we could keep going. 40 plus 360 times 3, and that's equal to 1120, and so on and so forth. So we have three positive coterminal angles. To come up with the negative coterminal angles, so again, these are the positive coterminal angles. To find the negative coterminal angles, we're going to take 40, but now we're going to subtract copies of 360. So k value of 1, k value of 2. We could pick any k value. We could do 10, 20. It just makes sense to use small k values here. And working these out, this is what we end up with. So what we did was we actually found three negative coterminal angles. So we did the first part of this question. We found two positive, two negative. Actually, we found 3 and 3 coterminal angles, and we found these in degrees. Now let's do it in radians. The first thing we want to do is we need to convert this angle from degrees into radians. So remember what we do is we multiply by pi radians over 180 degrees. That's going to end up with, well, we can divide both of these by 10. We get 4 pi over 18 or 2 pi over 9. So that's going to be the angle we're starting with here. So to find the positive coterminal angles, we're going to add copies of 2 pi. Now to do this, we need to get a common denominator. This will be 2 pi over 9 plus 18 pi over 9. We get 20 pi over 9, so that's a first positive coterminal angle. Secondly, we're going to say 2 pi over 9 plus 18, this is 18 pi over 9 times 2, so 36 pi over 9, and what we end up with is 38 pi over 9. So we have two positive coterminal angles. And then for the negative coterminal angles, we're going to go in the same fashion, 2 pi over 9, but now we're going to subtract copies of 2 pi. So 2 pi over 9 minus 2 pi times 2. So we end up with 2 pi over 9 minus 18 pi over 9. We get negative 16 pi over 9. And then subtract 2 times negative 2 pi. We get 2 pi over 9 minus 36 pi over 9, negative 34 pi over 9.